Hello, I'm Andrew Kelly. I'm here to talk to you about what it looks like to write Redis modules in Zig and why Zig as a tool can help you with this use case. Let's jump right into it. So what does it look like to make a Redis module? Well, it looks like what it looks like to make any piece of software. So first we're gonna, mash some keyboard keys into our favorite text editor. Then there's the part where we try to make it compile. And then there's the part where we try to see if it works the way it's supposed to. And probably it doesn't, and we have to debug it and then repeat. And then finally, once it works at all, we measure the performance, make sure it works well. Then we can iterate and get to the next feature. So let's do that. Let's just jump right into this. This is going to be a demo-heavy presentation here. So first we're going to do Hello World Redis module, and here we go. So first I'll switch you over to my terminal here. And what we're going to do here, we've got a directory, we've got some files in it already. But importantly, I've already typed up Hello World C Redis module so that you don't have to sit here and watch me type a bunch of code during this talk. The Redis API is quite nice. It's very simple. So all we have to do is include the header file, which includes the API definition. We register this onLoad function here, and this is going to run when our module is loaded. We call an initialization function, and then we call create command, which tells Redis about a new command called hello, and tells Redis about our function here. And our function is very simple. All we're going to do is reply with hello world. So there we have it. That's C code. Let's see what it looks like to build the C code. So over here, I'm going to run gcc-o hello.so. You can see I've already typed this command before. So there it is. I run it now. So this has produced the file hello.so, which we now can start the Redis server. I just ran it in this little terminal here. You can see it's running on this port. Now I can go over to this terminal here and I can run Redis CLI. Now I can run module load, and then I need the full path to that SO file. And let's see if I have it here. Okay, here it is. hello.so. Okay, so what this did is it loaded a new command that now Redis clients can use. And the command that I registered was hello. So there it is, very simple. That was C. Let's see what it looks like to do it in Zig. So back to the code. I did also go ahead and type in hello world Zig code for you. And here it is. So you can see it's roughly the same. Again, we're going to import the H file. Again, there's an onLoad function. We call the init function. We register our command, which references this guy, which is over here. Register the command hello. Again, we just reply with a simple string. It's the same thing. In fact, look what happens when I tab back and forth between the C version and the Zig version. You can see that the structure of the code is nearly identical. We didn't need any kind of bindings or anything special for this header import to work. And building it is also pretty similar. So I'm going to do Zig build lib hello.zig dynamic library, turn on the B symbolic just like we did here. We need to include the current directory, which has Redis module.h, and we link against libc. There we go. So that created this file, libhello.so.0.0.0. So you can see it has a little prefix and suffix here. And once again, we can go back into our client here. This time we'll do module unload hello module, I believe it was called. Yep. Now we can just load the Zig version, which is lib hello.so.0.0.0. Okay. And then same thing, we have a hello command. It's the same deal. Okay. So let's go back to the little presentation here. That's that. So what was the point of that? I wanted to show you that Zig has seamless interaction with Redis module.h. We didn't have to do any bindings or FFI or any kind of thing. It just imported all the C stuff, and we could just use it directly. It was the same code structure, same sort of build process, nothing to learn there. Okay, but now you're probably thinking, what's the point? Like, why are you showing me this? Why is it better if it's the same? Okay, all right, that's hello world. Let's move on to something a little more complicated. We're going to make a brainfuck Redis module. So what we want, obviously, is, I don't know why Redis doesn't already ship with this, but we obviously want Redis to be able to run brainfuck code and then print us the results. Of course. I don't know, why don't they already have it? So we're going to make a module for it. So let's go ahead and do that. So back to the terminal here. And again, I went ahead and wrote this code, so you don't have to watch me type it in here. And I'll just go over the structure so you can see what it looks like. So it's pretty simple. There's a code here that's just doing the brainfuck interpretation. And then here's the actual code that interacts with the Redis server. I'll go over this in a little bit, but you can see it has some arity checks. We're getting the source code, we're getting the max cycles argument, we're getting the standard input. Finally, we're printing a little program hash to the log. That's a nice little touch there. And then we have an error if the program exceeded the maximum cycle count. Okay. And that came out to what, 176 lines. So that's the C code. Let's look at the Zig code here. So it's basically the same structure. Again, we import the H file. We're also going to use some of the Zig standard library here. This code looks about the same. Same thing, we have the hash printed to the log, we have the cycle detection here. We got the actual brainfuck interpretation. Zig code came out to 158 lines compared to 176 lines. So that's pretty good. The Zig code was a little shorter. It's especially good considering we actually have unit tests in this Zig code here. So while developing the Zig code, not only can we build the brainfuck module, right, like I just did right now, I can also replace build lib with test, and I do need to pass these arguments still. But now it just runs a unit test. So now we know that the code's working and I didn't even have to touch the Redis server. But let's go ahead and load this up in the Redis server and see how that works. So just to show you again that built there. So that's going to produce libbf.so.0.0.0. So let's go put that into the Redis server. So I'll go ahead and unload hello module and load bf. Okay, and so now we have a bf command, and clearly it wants me to give it an argument here, and I will do that. In fact, I will go and give it I'll give it the same argument from the unit test here. This is the brainfuck source code for hello world. So let's go ahead and put that into here. All right, so now the Redis server actually interpreted this brainfuck code and collected the standard out and then printed it for us here. And you can see that we also collected an optional maximum cycle argument. So if we give it, not enough cycles here, it's going to give an error. So let's see if we can get high enough here. Right, so it's somewhere between 400 and 500 cycles that it needs to run that hello world program. So that's the Zig code. The C code does the same thing. I'll go ahead and run that for you so you can see it as well. There we go. That created this one. So let's go ahead and load that up. Module unload, bf module, module load, lib, just bf.so. Okay, and then same deal. So I'm just going to pass in here. It's going to work. Great. So I skipped a couple steps here. You know, I showed you this development cycle here where you have, you know, test and debug. And you didn't get to watch me do the test and debug stuff because I already wrote the code here. So we sort of skipped that part. But I want to simulate it for you so you can get a picture of what it looks like. So let's say that I'm editing the C code here. And let's say that I did something wrong and this array access here goes out of bounds. So I'm going to simulate that by just adding, a big number here. And let's see what happens. So I saved that. So now I'm going to go over and recompile the C version. Now I'm going to go over and unload the module, reload the module, and now I'm going to run the command. Now remember, we just put a bug in there. Oh, that's bad output. Weird. Yeah, that's what happens when you have a weird bug. What happens if we put the weird bug over here? Okay, on that one we actually crashed the Redis server. Depending on how you interpret the situation, you might think this is a nastier bug or this is a nastier bug. But anyway, point being, the Redis server is dead. So what's going on here? Well, it was a seg fault. The Redis server did identify that bf.so is likely to blame. And it did identify that it was inside the bf command function here. So that's a good clue. But I mean, all we really know is that it's inside this bf module. We don't really know anything else. Let's look at what it would look like to make the same mistake in Zig. So I'm going to go ahead and go over here and do plus 5,000 here. So I made the same mistake in Zig. So now I'm going to go over and compile the Zig code again. So we'll start the Redis server over. And we need to unload the module. Oh, it's not loaded because we just restarted the server. So we need to load the module. In this case, it's libbf.so 0.0.0. Okay. So now, once again, we're going to run this code with the bug in it. Crash the server again. Let's see what's happening here. Okay, so it looks a little different this time. This time, we don't see seg fault. We actually see index out of bounds, and we get a stack trace. So Zig is actually showing us exactly where the bug is. It even put a little arrow here, helping you see that this array access was the problem. This is a lot more of a clue about how to fix the code than the seg fault we got from C. And there's one more reason that you might want to look at using Zig for writing C modules. So check this out. I'm going to go back in here and I'm going to fix this bug. So I pushed undo there. I'm going to fix it in the C code. I pushed undo there. So you can actually use Zig to compile C code. So up here, this is the command I've been using to build the Redis module for C, the C Redis module for the Brainfuck command. Now I can actually just delete GCC and change it to Zig CC. Same arguments, and it worked. So now we're using Zig as a C compiler. Now watch this. I'm going to go ahead and start the server again. I'm going to run module load again, except this time we want to load the C version. Okay. And now I'm going to run this command again. Okay, again the server crashed. What's going on here? Now it says illegal instruction. And once again, this is Redis's handler, and it's sort of only pointing out the vague location. But here's what happened. Zig identified undefined behavior in the C code, and instead of allowing undefined behavior to go into the Redis module, it put in a illegal instruction trap. So at least you got a crash instead of undefined behavior happening in your code. A crash is one of the legal ways to do undefined behavior. And it would be nice if they would show a little bit more clues here, and there's actually some stuff in the works for that to happen. But even so, this is pointing out undefined behavior. And I do know where it is because I was the one who put it in here. It's actually here where we're trying to print the program hash. So if you look carefully, you can see there's a multiplication here. And these types are actually signed integers, which means that we're incurring signed integer overflow, which is undefined behavior in C. So I can actually fix it by changing these to unsigned here. You have to be careful in C when you're doing hashing stuff. We don't have this bug in the Zig version because in Zig version we just have the operators that are explicitly wraparound addition and wraparound multiplication operators. So this is well defined. And now we've fixed it because in C you have to use unsigned integers in order to make this defined behavior. So now if I go back and build my Redis module with Zig, even though I'm building the C code, building the C code with the Zig compiler, now I can go over, start the Redis server again, load the module again, run the code. And now it works, and I'm sure that there's no undefined behavior happening here. We scrubbed all the undefined behavior out of the C code. Okay, so let's go back to the slides here. And what were the takeaways from that? So I just wanted to show you 3 things. First of all, I just wanted to show you that writing the correct code is just easier in Zig in the first place. So we didn't have the, first of all, we can write unit tests, and that's just really easy to do. Second of all, we didn't have the undefined behavior in the hashing code. And thirdly, when we did have a bug, it showed a stack trace, and it just showed exactly how to fix the bug. There's a little arrow pointing right to the bug. So testing and debugging is streamlined in Zig. That's what I wanted to show you. Then also, Zig is kind of a better C compiler. It's just, even if you're going to write C code, Zig can help you scrub your C code from undefined behavior, and it just has better defaults. And I'll show you another reason why it has better defaults in the next section here, with performance testing. So this is the next step in the development process of any software, it's performance testing. So let's go ahead and do that. I already collected some results, and I'm going to show you a little table on the next slide, but let me just show you my process. So if anyone wants to try to repeat it, they can. So back to the demo terminal here, and let's go over here. So we're going to use these same files here, and let's just make sure these bugs are fixed. Yeah, okay, this is all fixed code. And then benchmark stuff. Okay, so I already wrote a little benchmark snippet that I can paste at the bottom of the Zig code here. And now I can run. This is just the same code here, and it's just going to run a whole bunch of times, and it's going to time it. And it's going to take like a little over a second or so. So now I can run zig test df, or whatever. We already did the test, right? Zig test. So this is all I need to do. And then I'm going to use release fast, because we're testing the speed here. Okay, what is going on here? Oh, okay. I changed the way this code is working, and I forgot to update the benchmark code there. Okay, so that should fix that. All right, so now we're compiling in release fast mode. I'll run this a couple times, and you just sort of get like a ballpark estimate of the time here. So there you go. So there's a little performance testing for the for the Zig code. I also wrote a little benchmark we can paste at the bottom of the C code here. So I just basically gave it a main function and added some timing stuff here. What's going on here? Oh, it's the same deal. Okay. Okay, there we go. So now I'm going to go over and so I can show you, for example, here's what it looks like with GCC. GCC bench C bf.c, and then I think we need O2 for go fast. Let's go ahead and run that a couple times. Okay, so these are roughly the same here, and I am running OBS, so it kind of throws off the benchmarks. Let's try Clang, and again, run this a few times. Okay, Clang's doing a little better than GCC here. And let's run, finally, let's run zigcc, and then run that a few times. Okay. That's actually doing pretty good as well. So that gives you some ideas what these times look like here. But I want to show you the results that I got when I didn't have my OBS just sort of like making everything whack. So let me zip over to that here. So this is what I got when I before I did this recording here. What I found was that GCC was the slowest, Clang was faster by 12%. This is the C code. I found that the Zig code was 7% faster than the Clang 7 compiled C code. And I actually found that the Zig CC on the C code was even 2% faster than that. Very close though, within error margins of each other. You know, there's regular caveats apply with benchmarks. It's like you can't use this to like really truly understand something. So this is not scientific, is what I'm trying to say. But here's what I want to communicate with this. A lot of other languages will sort of advertise that they are, you know, only a little bit slower than C. You know, like, oh, we're within, you know, 10 times slower than C or something like this, and that's good. But that's not what Zig is doing. What Zig is doing is saying we're trying to beat C. Okay, maybe on not all the benchmarks we're going to win, but we're trying to beat C at speed. That's what we're looking at. And I mean, come on, give Zig a little break here. It's only on 0.6. These other compilers have had a long time to iterate here. So that's it. Just wanted to show you, that's kind of the performance ballpark that Zig is aiming for here. And I can also explain this, by the way. The reason zigcc is so fast is that Zig is a cross compiler. Zig has a very good understanding of what target you are trying to target, or what you're trying to build your code for. So in this case, GCC and Clang, they have defaults that say that the defaults of GCC and Clang are some kind of weird mix between cross-compiling and native compiling, whereas Zig is very explicit. You're either cross-compiling or you're native compiling. And in this case, we're native compiling. So zigcc was able to take advantage of all the CPU features that my CPU has, and that you wouldn't assume are present if you're cross-compiling. And that's a good reason to use zigcc, because that's a better default than the C compilers. So that's it. Thank you very much for watching my talk, writing Redis modules in Zig. I hope that if you haven't checked out the project, you'll take a look. It's definitely immature, but it's also very ambitious and exciting. And if you want to get involved in a new language that's entering the space, I think you would have a good time. Thank you very much.